When I repeat myself, I try to do it quickly. So let's do this quickly. I went over the 3 ways that CO2 is transported earlier. This would be CO2 unloading from the systemic tissues, body tissues, and then so that's where most CO2 is. How is it going to be carried? Most of it is going to be carried as bicarbonate. That's HCO3, dissolved in the plasma. We'll see how it gets to that form next. That's called bicarbonate, and that's about 70%. About 7 to 10% is just going to be dissolved in the plasma. It's more soluble than oxygen, carbon dioxide is. That's just going to contribute to the PCO2, just free CO2 in the plasma, dissolved. Then lastly, we've got bound to hemoglobin. So 1, 2, 3, about 20% is going to be bound to hemoglobin. That's HbCO2. Let's draw you this equation quickly for carbon dioxide combining with hemoglobin. It's going to be easier than this other one we're going to get to later. CO2 plus Hb can go both ways, HbCO2. So carbon dioxide can actually bind to hemoglobin. You already know this because you know about the Bohr effect. That's due to high levels of carbon dioxide represented by high PCO2. That's going to contribute to the shift in oxygen hemoglobin saturation that allows for oxygen unloading. So by having high carbon dioxide, you also enable high oxygen unloading. And that's through this relationship with hemoglobin directly. It changes the shape of hemoglobin. The one thing we haven't done yet is that more complicated equation that results in bicarbonate formation. So I'm going to draw it up here, and then we'll see where it is in the blood. So the chemical reaction is going to be a little more complicated than our hemoglobin ones. CO2 is going to combine with water, H2O, reversible reaction to form bicarbonate plus a hydrogen ion. This reaction is carried out by carbonic anhydrase. And this hydrogen is going to lower pH because that's what pH is. It's increased hydrogen. So increased H plus is going to result in low pH. Let's look at where that happens in the blood here. So this looks more complicated. Same thing though. Carbon dioxide is unloading from the tissues, combining with water via carbonic anhydrase. This enzyme is going to be converted to bicarbonate, is this one. Same as this, bicarbonate. I want to actually make sure not to cover up the negative there. There it is. And a hydrogen ion. That is how the bicarbonate is formed, which is about 70% of CO2 is carried. Not actually CO2 anymore, right? It's converted into bicarbonate. At the tissue, at the lungs, that's going to be reversed. This hydrogen ion is actually buffered by hemoglobin. So there's a Hb, hemoglobin binds to it. That is going to shift hemoglobin affinity and shift it to the right. So that is that Bohr effect. This is actually a buffer system for acids, hemoglobin buffer system. Okay, what happens then in the pulmonary capillaries? The opposite, right? So this is this direction happening here. We're going to go the opposite direction. I'm going to show you a figure. Going to be a little complicated. I'll tell you which of this stuff you should know. So here is our tissue cell. This is what we just did. Let's first review that. Dissolved in plasma. That is our about, oh, this color isn't showing up. 7 to 10% is this. Then we've got carbonic anhydrase. I don't need you to know the difference between the slow and fast. There's two different locations for that enzyme. That's what is happening here. These are the same. In either way, carbonic anhydrase is producing bicarbonate and hydrogen ions. This is, in this form, about 70% of carbon dioxide carried. Then number 3, we've got carbon dioxide binding to hemoglobin. Carboaminohemoglobin is formed. There it is. And this, make sure that's right, is the 20%. This is all happening primarily in this direction, in the tissues of the body. We're looking at carbon dioxide. Oxygen is unloading from hemoglobin at the tissues. This right here is facilitated by the presence of this low pH and high PCO2. This carbon dioxide being added on here is facilitating this, and that's the Bohr effect. Then in the alveoli, the opposite's happening. We've got oxygen loading, and that's facilitated by no longer having a Bohr effect. And then for carbon dioxide, we've got carbonic anhydrase carries out the reversed reaction, right? So this way, and that is facilitated by this being high, right? And PCO2 being low, so it facilitates the chemical reaction in that direction. And I'm sorry, I squared that in the wrong spot though. That should be these two, is the carbonic anhydrase. And then lastly, dissolved in plasma. This is just diffusion, straight up carbon dioxide diffusion.